The velocity. Okay, so the area under the curve represents what under velocity? When you add up all those things, what does that represent? The what? No, it does not. Key difference is the displacement, right? The balloon's going up and down, right? So if it's positive, it's going up, and if it's going down, it's going, well, if it's going negative, it's going down, right? So if you don't know where it starts, can you tell me where this balloon is? Like if I tell you, hey, a car is going 100 miles an hour, where's the car? That question makes no sense, right? So this basically is telling you how fast the balloon is going up or down, right? But without some sort of fixed point, you can't tell where it is. So on O, what does it tell you? What's the first thing it tells you in O? It says it starts at what? So it's basically telling you that the position at 0 is what? It's saying S of 0 is 70, right? In the first, is it seconds? Is it seconds?
I don't think it says. It just says time.
Okay, time. In the first 8 units, and does it give you a unit for going up and down? Well, it doesn't really matter, actually. You can answer this. But the point is, how much has it moved in the first 8 units of time? Let's call it seconds. In the first 8 seconds, 24 feet. Let's say feet, okay? Up or down? Up. So at 8 seconds, how high would it be? 94. 94, okay. So then, if it went so right here, then it would be at 94 feet, right? High? And then what happens over the next 8 seconds? It goes down what?
32.
It goes 32 down. So where is it at 16? How high is it at 16?
62.
62. So it's gone up to 94 and then down to 62. So on O is asking you, it says, HALMNO, it says, if at time 0 the height of the balloon was 70 feet off the roundabout, what time will the balloon return to that height? Return to that height. So we know that if you go to 16, it's below where it's started. It's below where it's... Yeah, so you're looking for the net change. And actually, is the 70 relevant in this question?
Not really.
Not really. It's asking when is the net change, the displacement been 0, right? Doesn't matter where it started for the displacement to be 0. I go 10 miles that way and 10 miles that way, my displacement is 0. It doesn't matter where I started, right? So you're basically looking for the point where it's at 70, which is where the displacement is going to equal 0. You know it's going to have to be, you have to take away 24. So you're trying to figure out at what point is the area of this thing 24. In this case, negative 24, right? So it's asking, it said estimate on this one, right?
Yeah.
It didn't say do it exactly. So you can't really do it exactly because you don't know what the exact points are right here, correct?
Yeah.
You could estimate what those are and then make it linear lines. But the point is, so for example, you could say, let's go to 12 right here. Let's estimate what this is. What's the area right there? So the whole thing is 32. What's this?
16.
So that right there would be 16. So it has to be further than that, right?
Yeah.
So it has to be, and then what's half of? So the rest of this is 16. So if you know not to here, but let's say you you just go a little bit further. You need to go not to 16. You need to make it what? 24. So you need 8 more.
Mm-hmm.
So maybe something like here, right?
Yeah.
Maybe something like that. So maybe something around what?
13.
Around 13. It might be a little more, but it's around 13. That would be a decent guess. Does that make sense?
Yeah.
So actually, is that 70 part of this problem at all?
No.
Doesn't really matter, right? To answer that question. Okay.
Thank you.
Okay. We talked about this last class, just as a recap. The key thing about this rule right here, what letter was the really, really important one? They're all important, but which one's really, really important? The B, exactly, Caleb. You have to have that same value or it doesn't work. If you don't have that value, there's a gap. And where did the starting point, it goes from A, so it has to start at A, and then it goes to C, so it has to end at C. And then what's the other key thing that it's kind of so important that we didn't say it before? The function has to be, f of x, the function has to stay the same. If the function changes, none of that makes sense. And then what do you have right here? What can you do with this constant? What can you do with it? Yeah, you can factor it out. And what does that have to be? It has to be a constant. And the way you can figure that out if it's a constant in relation to what's being integrated. How can you tell what's being integrated? How can you tell which variable is being integrated? It's written up there. How can you tell which the what? Yeah, the x, but actually that's not what tells you what's being integrated. It's the dx. You see this right here? That tells you that x is changing, okay? X is changing. So therefore you can't pull out x. You could pull out anything else you want, but you just can't pull out x. It also be multiplied too. And then what does this say? Well, if you're integrating the sum or difference of two things, what can you do instead? What can you do instead? You can break them apart. And this can be very helpful just in terms of keeping track of what's going on. The other key thing to remember is you can always go backwards on these. Yeah, sometimes, yeah, you want to glue them together. Sometimes you want to add the functions together and they might cancel each other out. Things like that. Like you could have a huge function here and a huge function here, but when you add them together, 10 terms cancel and you're left with one. There are reasons that you want to go backwards sometimes. Sometimes. Okay, so let's do this right here. Everybody stand up, please. So let's take a look at this. This is asking, I have a question for you. There's a word up there you haven't seen before. What's the one word on the board, Mikey, that's new? Oh, you need to, sorry. What's the one word on the board that's new? That's a little bit more challenging here. So here's the thing. There are three things here. So you do them each individually. Let's do the easy ones. What's the antiderivative of 1? That would be x, and there's a plus c, right? What about 2x? We knew that one, right? What about this one right here? Oh, it's just x cubed. Works out nicely on this one, right? So the answer here is indeed pretty straightforward. Pretty straightforward. Integrating polynomials will get real quick in your head. When you have a polynomial integrating, it will get real fast. Are there lots of other types of functions? Yes. Are there lots of other formats of polynomials? Yes. So is it going to get more complicated? Absolutely. But the bread and butter is this. This is the bread and butter. Okay, so let's take a look at this. What the heck? You know it's going to be x to the what power? Fifth, but when you bring a 5 down, you need it to cancel with 1 over 5. So in this case, n is what? 4. So then it becomes n plus 1. And what's that 5 right there? N plus 1 to cancel it out. Absolutely. Could there be other fractions in play? Absolutely. Does this rule change if you're working with fractions? No. It doesn't change. It doesn't. What's the only difference between this line and the second line? What's the only difference? The a. There's a constant, right? Here's the thing. What did I tell you about constants? What can you do with constants? You could just put it out here and ignore it all the way until the end. It just goes on top because what's a times 1 over n plus 1? A over n plus 1. So you can ignore those until the end and it multiplies back in. So try this one by yourself right here. Try this one, everybody. Try that one. No, just each piece. You do each piece. So what's this one going to be? X to the 5th over what? Are you sure? It better be 3x to the 5th over 5, right? Okay, got it. Minus what? 5x to the 4th over plus. Yeah, you get the hang of this, right? Plus what? 8x squared over 2 plus. Yes, and can you simplify some of these fractions? I have not. Why have I not specifically not simplified any of these? To show the pattern, right? The 3, the 5, the 2, and the 8 are just along for the ride. So that becomes 5, but you have to cancel the 5 out. That becomes 4, you have to cancel the 4 out. Yes?
I thought it was a over x.
Can you evaluate definite integrals? Absolutely. Take a look at this. Don't do it, but take a look at this. Can someone tell me what the indefinite integral of this is going to be? What is the indefinite integral? Or x cubed plus
2x squared over 2.
it's just x squared, right? Plus c, and you're evaluating that, and I'm going to show you some notation here. You're evaluating that from 0 to 5. See that bar? That is super common. That means evaluate from 0 to 5. So what's that going to be? That means the first thing is 5. Why am I doing so many parentheses? I don't know why. 5 cubed plus 5 squared plus c minus 0 cubed plus 0 squared plus c. So that's going to be 125 plus 25. So that's 1 what? 50. So Caleb, you were asking, do you need to write the c right here? Technically, no, you don't. You don't have to. Because the c is always going to cancel when you're calculating a definite integral. That's fine. If you did this, am I kind of happy? Yes. I am. Okay, why don't you try these two by yourself. Try those two. Totally fine. On this one right here, you first have to find the indefinite integral, right?
Yeah.
So what's that going to be? Well, 2x to the 4th over 4 plus 1/2 x squared, right? Plus c from 2 to 4. Then you just have to evaluate it really carefully, right? So what's that going to be? It's going to be 1/2 4 to the 4th plus 1/2 of 4 squared plus c minus 1/2 of 2 to the 4th plus 1/2 times 2 plus c. So what do you end up with there? Say 250, what, 128?
Yeah.
128 plus 8 plus c minus what? 8 plus 1 plus c? Is that correct?
Yeah.
I think it's right.
Yeah.
I need help though. 136 minus 9 equals what? 120? 127? Mikey found it! I totally thought I was right. I'm totally wrong. Look, this should be squared, right?
Yeah.
There's a square. Look what I missed. I totally missed the square. So that's squared. So what does that make that this becomes a what?
Or a 2.
It becomes a 2, right? So what does it be? Actually, this becomes a 10. So this whole thing becomes 120 what?
6.
Good job, Mikey. Mike, you get a gold star. The integral from 0 to 4 of
2x.
squared plus 4 dx. Yeah. So that's going to be 2x to the third over 3 plus 4x plus c from 0 to 4.